Okay, today we're going to be talking about 1.6, and in 1.6 we're going to solve equations of different varieties, and it's just, there's not one set of rules that we're going to follow. It depends on the setup, it depends on what we're looking at. And we're going to be looking at these different varieties. Polynomial equations that we can solve via factoring. Typically this is called like a GCF factoring, greatest common factor. Pull that out and see if you can solve it then. Radical equations have root symbols. It could be a cube root, most of the time it'll be a square root. Rational exponents are things like x to the 2/3 power. How do we deal with a 2/3 power? Equations that are in quadratic form, they're not going to be quadratic, but they'll have a pattern that we can recognize, like x to the 6th plus 3x cubed plus 8. If you look at the 3 and the 6, 6 is twice as big as 3. This looks quadratic in nature, like x squared plus 3x plus 8. 2 is twice as big as 1. 6 is twice as big as 3. So these would be very similar in that they're both quadratic in nature. The top one is not quadratic, but it's similar in the way it's built. And of course, absolute value functions like x plus 7 equals 3, and we can go through and solve that. So those are the different types we're going to look at. We'll start with solving when we can factor. Like always, we want these things to equal 0 in most cases when we're doing the physical solving. So I'll rewrite this as 4x to the 4th minus 12x squared equals 0. And then I'm going to look for commonalities. I notice both of these divide by 4x squared. And then that leaves me with x squared minus 3. What this allows me to do is to think about the outside as one object and the inside of the parentheses as a separate object because they're multiplied. So if the outside is 0, it doesn't matter what's on the inside. If the inside is 0, it doesn't matter what happens on the outside. So in order for this to be equal to 0, plugging in 0 for x would make 4 times 0 squared be 0. This one's a little bit tougher because it's not just x minus 3. So I can't just say it's plus 3. I actually might want to take and let the whole thing equal 0 and go through the process of solving. I would add 3. X squared would equal 3. And then to get rid of a square, I'd take a square root and stick a plus or minus in front. And so now that means that I have positive root 3 and negative root 3 for a total of 3 solutions to the problem set. All right, so there's our solving when we're factoring, pulling out common terms. Then we have another case where we're dealing with square roots or some sort of a radical in the problem. The first and most important thing is to make sure that the root is isolated. This is the root. I want it completely alone. I can't really move forward without taking care of that right now, so I'm going to move the x. So the square root of 6x plus 7 equals x plus 2. Now I'd like to get these x's together, but one of them's inside the square root. The only way to get rid of that is to square both sides. But when you square the right, you have to go through the FOIL process. These will cancel, leaving me with 6x plus 7 equals, and if I think about x plus 2 times x plus 2, I'm going to get x squared plus 4x plus 4 because there's 2x and 2x. There's our 4x. That makes this x squared plus 4x plus 4. At this point, this has become a quadratic in nature. Whoops. Sorry about that. So now we have a quadratic, and we know that we need to get it all equal to 0. So I'm going to move the 6x and the 7. So 0 equals x squared minus 2x minus 3. And of course, I want to try to factor if I can. So I'm going to go x and x. The 3 would factor as 3 and 1. It's negative, so the signs are opposite. And in order to get a negative 2, I'll go minus 3 plus 1. But remember, I'm still trying to figure out what x should be so that the equation equals 0. So over here on the right, the opposite of the negative 3 would be positive 3, and opposite of 1 would be negative 1. Now, whenever we're taking things out of a square root, we do need to check to make sure that the root doesn't become imaginary. 3 times 6 is 18 plus 7. That's definitely positive, so I'm not worried about it. Negative 1 times 6 is negative 6 plus 7. That's a positive one, so I'm okay there too. So my answers would be 3 or negative 1. If the square root had turned out to become square root of like negative 5, I would have rejected that answer, because that would mean my answer was imaginary, and it wouldn't necessarily work. All right, if we look at the next thing, okay, we have radical equations like this. We want to isolate this piece with the root. Because remember, when we have a fractional exponent, it means we really have a fourth root here of x cubed. That's what we're really looking at, and so our goal is to get that piece alone. So to do that, I'm going to have to add 6 to get 3 times x to the 3/4 equals 6, and then I'll divide by 3. So now x to the 3/4, that's my fraction, or my radical piece, and it is alone. It equals 2. To get rid of the 3/4 power, I'm going to raise this or multiply the exponent by its reciprocal. It's important that we realize that this is the exponent on the 2. It's not a multiplier. So x equals 2 to the 4/3. If I put that into my calculator, it ends up giving me a decimal. If the calculator gives you a whole number, circle it and be done with it. That's great. But here it's not going to work. It gives you like 2.5 something. And it's a mess. So what I'm going to do is I'm going to put this back inside of a root. It's the cube root, that's what this 3 tells me, of 2 4 times. So 2 times 2 times 2 times 2. And I know that it takes 3 pieces that are identical to get out of a cube root, and I'd be left over with that one single 2, making my answer 2 times the cube root of 2. And so the next type is where we're looking at something that has a quadratic form. The way that you know it has a quadratic form is that the first exponent is twice as big as the second exponent, and that you have a constant. So this looks a little like quadratic. So we're going to let t be x squared, which means x to the 4th would be t squared, because x squared would be x to the 4th minus 8t minus 9 equals 0. And now I can try to factor this. This is not the original problem, but it's something I can manage. I'm going to say minus 9 plus 1, which means t can equal 9 or negative 1. But remember, t is not my answer. X is. And so instead of writing t equals 9, I'm going to write x squared equals 9. I'm going to substitute back. And x squared could be negative 1. We know we take the square root here on both of these with a plus minus to get x alone, so that x will equal plus or minus 3, or plus or minus the square root of a negative 1 would be I. Now the book would potentially not accept both answers over here with the plus or minus I if it says only find the real solutions. But if it wants all solutions, then I and negative I are also solutions. But we use this concept of factoring that we use for quadratics. The last type of problem is when we're solving absolute value functions, or absolute value equations. Absolute value is the distance from 0, and we can move so many spaces to the left or so many spaces to the right. And so for that reason, okay, we have to realize that this absolute value could be 5 or could be negative 5. If it's negative 5, the absolute value would wipe the negative away. And so we're going to look at a negative version, and we're going to look at a positive version. And in doing that, we're going to be able to solve twice and find 2 solutions for the equation. When you look here, all we did was make a negative 5 and a positive 5. We didn't change the inside of the absolute value. But I'll be able to add 1 in both problem set. I get 2x equals negative 4, and 2x equals 6. Divide by 2 in both cases. And x will equal negative 2 or positive 3. We end up with 2 solutions. Turns out that if you go to negative 2 or to 3, you'll be 5 spaces away from what the inside of this equation creates. Okay? Good luck, and we'll see you in class.